anymore. Special thanks to 1700 Pacific for providing the space for today's session. Please share on social media using the hashtag DSW16. Please welcome our speaker, Adrian Fernandez. Adrian Fernandez is the Microcontroller Development Experience Manager at Texas Instruments. In his role, he is responsible for defining the microcontroller development experience and augmenting the way developers interact with TI's microcontroller portfolio. Today, Adrian will be walking you through some of the TI tools like the Launchpad development environment and the Energia development ecosystem. Great. Thank you.
Yeah, perfect. Thank you. Awesome. Good morning, everyone. Thanks for hanging out. I know there's a lot of really interesting tracks, so I appreciate y'all spending the next hour and a half or so hanging out with me, talking about rapid prototyping for the IoT. So I'm going to make this as dynamic, as interesting, and hopefully as sort of demonstrable as possible. And my main goal here today is to enable you all to walk away with a set of tools, or at least the awareness of tools that are available for building an end-to-end IoT platform, from the embedded hardware to the cloud service. And that's exactly what we'll be doing here today. So together we're going to build a connected product from the ground up. We'll be sending text messages, we'll be visualizing sensor data on a dashboard, reading things from moisture sensors to temperature sensors to potentiometer knobs. And hopefully that gives you a sort of snapshot of what's possible. And really, I think when you think about IoT, it sounds a little bit scary, especially for me. I'm more of a hardware guy. So when it comes to web development and the cloud, it's a scary world for me. I can blink LEDs and spin motors all day, but when it comes to RESTful APIs and sending text messages and talking to the cloud, it's an intimidating experience. And I don't know where you guys are coming from, whether you're more hardware or cloud or web, or maybe you're all of the above. So maybe we can both learn from each other. So maybe just a show of hands, who would classify themselves as more of a hardware guy? Okay, awesome. So y'all are maybe a little bit more like me, more web side. Okay, awesome. So we actually have a really good mix. And with IoT, right, those two worlds are colliding. It's pretty interesting where we're forcing ourselves to either wear multiple hats or work in cross-functional teams where we are able to provide a complete system solution for our customers to solve interesting problems. As a very quick demonstration, I'm not solving world peace here, but using, again, this whole mantra of rapid prototyping, taking pre-existing open source hardware, some of the software tools that we'll be going through today. I mean, what we're doing here is we're listening for all tweets that are tweeted at the hashtag DSW16. So if y'all want, just send a tweet. It should magically appear here on the scrolling LEDs. So super simple demo, but what we've just done here is, again, bridging those two worlds, using hardware to control the segmented LCD displays, but then also interacting with cloud services like Twitter, and using the APIs that they expose. And in this case, we're basically just looping through the latest tweet that hits the DSW16 Twitter feed. So what could this do? I mean, this could be a lot of things, right? I mean, in a real application, I'm coming from TI, we work with a lot of industrial customers, and they want to be able to get remote notification when their industrial plant is exceeding certain thresholds or temperatures exceeding a dangerous level. So in this case today, it's showcasing tweets at hashtag DSW16, but the exact same technology is what we're giving to our traditional customers to enable them to do remote notification from a medical application to an industrial application to a consumer product. So hopefully this goes to show that what we're going to talk about here are just sort of fundamental building blocks that you all can mix and match together to create a complete system solution to solve a brand new problem. So with that, let's go ahead and jump in. I don't have a whole lot of slides. I wanted, again, to keep it much more hands-on, more demonstrable. Let's see here. I don't know if anyone's, that looks like an old tweet, so I don't know, we'll see. We'll see if it continues to work throughout the presentation. A few things, if y'all have any questions on anything that I've talked about today, I've put my email up here, adrianf@ti.com. So feel free to reach out to me, whether it's about anything we've talked about today or just TI's portfolio as a whole. I can do my best to close the loop and get you in front of the right person inside of TI. Follow me on Twitter, that's my Twitter handle, and also that's a TI Twitter handle, so feel free to tweet at us. I know corporate likes to see Twitter activity, and that allows me to come out to events like this more often. I get free breakfast tacos, and everybody wins. It's a win-win situation. So my name is Adrian. I've been with TI for about 6 years now, and I started the Launchpad platform at TI. One of the most important things that we have inside of the TI portfolio is our breadth. If you go to a lot of the semiconductor vendors out there, they might specialize on microcontrollers, they might specialize in processors or analog devices or sensors. TI, I think, is the closest thing to kind of clean sweeping that bill of material. We've got both the analog and the embedded product portfolio to enable you to complete that system. And Launchpad is probably the closest thing that we have of enabling customers to get that shotgun coverage of our portfolio that's 80,000 products deep. So by taking some pre-existing modular hardware, which we'll be demonstrating today, you can again build that complete system, whether it's microcontrollers or wireless connectivity or power management or sensor interfaces or displays. Because really, when you think about it, most applications, most products are made up of those same building blocks. I mean, a lot of the differentiation comes through software. So that's Launchpad. Really what we're trying to do is enable makers, students, hardware startups, as well as the traditional Fortune 500 companies, right? Obviously, the big guys pay the bills, but we understand that the innovation is coming from startups and students, and we want to make sure that we're enabling those folks as well. And hopefully, as I go through some of these tools, some of these demonstrations, you'll kind of see that we are really lowering that barrier of entry. One, from an economical perspective, like these Launchpad boards start at just $10. So for the cost of like a Chipotle burrito, you can start programming a microcontroller. In addition to that, the software tools are all open source and free. So again, trying to get our technology into as many people's hands as possible, making sure resources are available, supporting events like this, I think that enables us to sort of democratize embedded development. And in short, the moral of the story is that everyone benefits from rapid iterative development. While it's traditionally partnered with hardware startups and sort of the maker movement, we're seeing traditional customers as well using that sort of mantra of iterative rapid prototyping. Logitech, for example, will be there in 2 weeks to introduce them to the exact same demonstrations that we're going through here today. So I mean, this exact same technology is enabling that entire spectrum from beginners to makers to hardware startups to our traditional customers as well. Let's see here, do I have any more slides? So this one here is kind of just the bird's eye view of what we'll be doing here today. One, the main primary goal is to give you resources both on a hardware, software, cloud perspective to enable you all to build an MVP that's connected to the cloud. So we're going to be going through a ton of cloud services, a bunch of third parties, a bunch of TI homegrown solutions, and by pairing those together, I think you all will be well equipped to build a connected thing. So we're going to be going through a whole bunch of these. I don't know if any of these like buzzwords or partners or names here ring any bells, but these are the things that we're going to touch on today. So with that, I'm just going to jump into a demo here, guys. I think you guys will be really interested in this company called Tembu. Has anyone heard of Tembu? A few of y'all. So mind-blowing, right? I mean, if you guys have used it, it's the coolest thing. It's my favorite thing to showcase, simply because it's super, super easy and extremely powerful. So I apologize to the two that are aware of this service, but hopefully I can share a few things that maybe you aren't familiar with. So I'm going to go ahead and jump right in. All right, so the first thing, Tembu, it's a cloud service. They're a little bit different from maybe some of the cloud services you're familiar with, like Amazon AWS, IBM have Bluemix, there's a bunch of smaller guys like Exosite and ThingWorks. Most of those traditional cloud services, what they're doing is they're receiving data from a connected thing, whether that's through a RESTful API or Mqtt or CoApp, and they're basically doing big data analytics. They're enabling you to visualize that data, trend that data, connect it to a widget so that you can see it over time. That's all extremely valuable. Tembu's a little bit different. So they're a cloud service, but what their goal is enabling you to very easily interact with hundreds of web services that provide a RESTful interface. So FedEx.com to Facebook to Google to Twitter, they all expose some level of interaction through a RESTful interface so that not just hardware, but also other cloud services can interact with the value that they provide. So this is what I think is coined the sort of API economy, right? All of these cloud services exchanging data, and that's just the way the internet works today. And now that my embedded hardware has the ability of connecting to Wi-Fi, I can take part in that API conversation. And suddenly my little tiny microcontroller can start talking to Twitter, or I can talk to ESPN to see what the latest scores were from last night's game, so on and so forth. And Tembu makes that extremely easy. So I've already signed up for an account. It's free for, I think, 10,000 uses, and I can go into more detail on the business model and their pricing. But they've been working with us for about 2 years now. And we've got really tight integration of our Launchpad hardware into their cloud service. So here on the left is a huge list of the cloud services that Tembu supports. So again, these are all existing web services that expose some level of RESTful interface. So you'll see a lot of familiar names. There's a bunch of cloud services that I'm not even familiar with. Maybe some of these will ring a bell. But you'll see Dropbox, eBay is here, FedEx, Google, Uber is here somewhere, so on and so forth. So as a very, very rudimentary example, let's say I wanted to take this little guy here. This is a TI microcontroller paired with a TI Wi-Fi module. So this is more or less, from a hardware perspective, a connected thing. I can connect to Wi-Fi, connect to my home network, send and receive data to the cloud, interface with any of these websites that you see here on this list. And let's say I want to blink that little green LED here whenever my package arrives from FedEx. So there's a few things that I can do, right? I can go to the FedEx.com website, sign up for a developer account. They've got their API fully documented on the web, right? And this is going to be a RESTful HTTP interface. So I can curl to it if I wanted to from a Raspberry Pi or a BeagleBone or my terminal, or connect to it and talk to it using my sort of $20 piece of hardware. And normally I'd have to write that code in some low-level C language, right? It requires me to have some understanding on how to program this guy to connect to Wi-Fi and talk that RESTful interface. Tembu made it extremely easy, where I can simply go here to FedEx, click on tracking and visibility, and click on track by number. And again, because we've been working with them so long, they've actually added Launchpad support directly into their website. So I simply say, hey Tembu, I'm using my TI Launchpad board. I've got the CC3100, which is our Wi-Fi network processor that's paired with our micro. So it's a two-chip solution. You've got a microcontroller, which sort of hosts your application. That's your secret sauce, your code. And then we've got a Wi-Fi processor that enables the internet connectivity. And I simply scroll down here to the bottom, and I provide it a few parameters, like my FedEx account number, my FedEx authentication key, and then lastly, my FedEx tracking number. And just like that, it generates the entire code for me. I simply hit copy, and I can paste it into my IDE. Oops, I guess I didn't copy it. But you get the point, right? I'm able to copy it, paste it, flash my hardware, and just like that, my Launchpad is going to query FedEx.com every 30 seconds. And that duty cycle, if you will, is just simply defined here in the code. So after each request, just delay for 30,000 milliseconds. So Tembu made it extremely easy to do what I would call the hard part, connecting to Wi-Fi, talking the RESTful API. I can even have Tembu pre-filter the XML coming from FedEx, because FedEx is going to give me a ton of information. It's going to say the last time it was updated, where it's coming from, current status. But if I only care about current status, I can actually have Tembu pre-filter that XML so that my little tiny microcontroller only gets the little string that I personally care about, and that's status of my package. So now all I have to do is add the 2 or 3 lines of code that says if status equals delivered, digital write LED high. Does that make sense? So it makes the cloud part of the system extremely easy. And that user experience is available for all of those cloud services that we saw on the left. So just like that, we just sort of hypothetically created a very simple FedEx notifier. Or I could have hooked it up to what's now not working. Let me hit the reset button. This little guy. So that instead of showcasing the latest tweets for a certain hashtag, it's actually showcasing the latest status delivery of my package. And Tembu makes that extremely, extremely easy. So that's Tembu, and I'm actually going to now go and build a application going through the exact same user experience, but using another cloud service that might be interesting for some of y'all, and that's Nexmo. Anyone familiar with Nexmo? Yeah, 1, 2, awesome. They're a great cloud service. They provide a RESTful API for triggering voice calls, which is interesting, again, for a connected thing. So let's say, again, we're talking to one of our industrial customers, and they're monitoring water levels in a plant, in an industrial plant. And they may not always have someone on-prem to monitor that water tank, as an example. So when that water tank exceeds a certain threshold, I want to use a cloud service like Nexmo. So I can have my little tiny microcontroller connect to Wi-Fi, use the Nexmo API and trigger that voice call. And using the cloud, I can then do some text-to-speech conversion, and I can actually have the cloud vocalize to me a message. And again, we're going to do that in like 2 minutes. So I'm just going to click on Nexmo, click on voice, and click on text-to-speech. Again, I'm using my TI Launchpad with my Wi-Fi plugin module. I've already saved my Nextmo credentials to my Tembu account, so it's going to go ahead and pre-populate a couple of fields for me. Awesome. And then a text field. This is where I can type in the message that I want to have vocalized to me. So I'm going to go ahead and type alert. Alert. Put this down. And basically, what this does is just like the FedEx example. It generates the code for me. You'll even see the text message that we just typed up there, dynamically building the code in real time. And it's just going to call my phone every 30 seconds. That's cool, but it's not going to be very friendly to my cell phone bill. I only want to call my phone when a certain sensor condition has happened or it's occurred. And Tembu actually already does that for me, where I can say, hey, I only want this to happen when analog pin 6.1 is, I don't know, greater than 50. So only when that certain condition is met will it call my phone, and it went ahead and added that very simple if statement for me, which you can see here. If sensor is greater than 50, only then connect to Wi-Fi, call the dude's cell phone, and let him know that, hey, things aren't so hot in your house right now. So I can hit the copy button. I don't know why I don't think it's like a Chrome thing. That copy button isn't working for me, so I'm just gonna do it the old-fashioned way. This is like the hardest part of the whole thing, is manually highlighting the code. So I'm just gonna copy that into my environment. And I'll talk more about this here, but if you've developed with an Arduino before, this should look very familiar. This is basically our fork of the open source Arduino project. And this enables code compatibility with the Arduino framework and our hardware. So a lot of the same APIs you might already be familiar with are gonna be very, very similar. I do need to add a new tab called Tembu account.h. And this is just a separate header file that includes things like my Wi-Fi credentials as well as my Tembu account credentials. And it actually generates that code for me as well. So I've already added Startup Week Wi-Fi, which is the open network that we have here. Let's copy that dude, paste it in to that new tab that we just created. And that's it on the coding side. So now let's think about the hardware. So again, using open source modular hardware from companies like TI, as well as our partners, everything we release and is orderable from the TI website is what we call open source hardware. So we release the schematics, the PCB layout files, the bill of materials for each layer of this sort of launchpad booster pack sandwich. So booster packs are what we call these plugin modules. As we mentioned earlier, we have a Wi-Fi 1 paired with an MSP430, which is a TI microcontroller. And then on the bottom is a very simple interface board that allows me to connect to sensors like this one. This one here is a little potentiometer knob. So I can turn it, rotate it, and I get a different voltage based on the position of that rotary wheel. And I'm actually going to replace this guy because we said flooding, right? So I don't care about the position of this knob. I actually care about moisture. So I'm just going to unplug it, and I'm going to go into my box of sensors here, which again, I'll also talk a little bit more about. But one of the sensors that we have is this guy. It's a little sort of probe, if you will, that I can stick into my flower pot, and it'll tell me how moist the soil is. Or again, in that industrial application, I can place this inside of that big reservoir, and whenever moisture makes contact with these probes, at that point, I get the voice call. So I'm gonna go ahead and plug it into this little ribbon cable. And just like that, hardware-wise, we're done. We've got a microcontroller, our little reprogrammable brain, if you will, the Wi-Fi module, which enables the cloud connectivity, and the sensor reading the real-world value that we care about, in this specific case, moisture. So I'm just going to go ahead and plug it in over USB and hit the program button. So let's do that. There you go, it says Wi-Fi okay. The first thing it does is it starts to read the sensor, and we're gonna get the latest and greatest sensor reading here. So no moisture, right, because it's sensing the air. I'm just gonna lick the sensor, so don't judge me. I'm gonna do it. So I'm gonna lick the sensor. It's gonna exceed the threshold that we programmed into it, and I'll put my phone on speaker as well so that you can hear the message that we've just programmed it with. It's like a magic show, guys. yeah, exactly. So I'm gonna lick the sensor. All right, 1, 2, 3, go. There you go. So there you get the HTTP 200 response, which is usually a good sign. Hopefully my phone starts ringing here, and I'll put it on speaker. There we go.
Alert. Hello, Adrian. Your house is flooding. Good luck with that.
Yeah, that's it. Crazy, right? I mean, that took like 2 minutes. Out of control. So what's so cool about this? First and foremost, there's at its bare minimum, at its core, there's 2 knobs you can turn. Knob number 1 is what real-world value do you care about? Is it moisture one day? Is it temperature? Is it ambient light? Is it motion because you want to build a security system? So that's knob number 1. You know, what do I care about in the real world? Knob number 2 is what do I want to happen in the cloud side? Is it sending a text message? Is it sending an email using Google or Gmail? Is it calling a car with Uber? The possibilities are, I wouldn't say endless, but it's a pretty big number. So just to demonstrate just how easy this is, right? This is simply creating an analog voltage reading, right? Based on the presence or non-presence of water. Because of the modularity of all of this, I can easily unplug it and replace it with that turn knob instead, or replace it with the ambient light sensor instead. So let's just do that just for good measure. But first, let's pick a sensor. Let's go with the ambient light sensor, and let's say I only want to call my phone whenever it's too dark for whatever reason. So I'm gonna go ahead and simply make a small change in that code, and that's really just gonna be the inequality that we have here. So only when it's really dark do I want to call my phone. And then if I wanted to, right, I can change the message by simply modifying that string wherever it is, that guy. So I'm gonna go ahead and hit the compile button and flash our hardware, and while it's doing that, I'm gonna unplug the moisture sensor, replace it with the ambient light sensor. So let's go ahead and do it. So I'm not even, oh my gosh! I think we're okay though. I think we're good. All right, let's see. There you go. It's still working. All is well. So it's going to again try to connect to Wi-Fi. We're going to get the sort of ambient sensor reading from the sort of light that we've got in here, and it should be above the threshold. So that's the just raw reading coming from the ambient light sensor. So I'm going to cover it up. Value goes down again under 50. Now it's calling my phone. So we just created 2 kind of seemingly different applications solving different problems, same sort of result. So I won't do it again. But it just goes to show how easy it is to sort of pivot, right? You might have one application one day, you hear customer feedback, you simply change the sensor, or you simply change the cloud activity, or you can do a sort of multitude of things where maybe you're listening to multiple sensors and triggering different cloud actions based on those various readings. So very high level, have I been blocking this thing the whole time? Y'all need to speak up if I'm blocking it. But yeah, if there's anything you guys want to do with hardware and software and cloud connectivity, Tembu is a great place to start because it doesn't really require a whole lot of sort of technical understanding. If you really wanted to, the code it generates is completely open and available and modifiable. So if you wanted to understand these sort of inner workings of everything, knock yourself out, go for it. Completely up to you. So Tembu, just to very quickly cover our bases here, its pricing model is interesting. It's basically, they charge you per API call. So one API call was that phone call, right? We just got charged twice for the 2 phone calls we triggered. But their pricing isn't too bad. I think it's down here in the bottom. Here we go. They've got a pretty good free tier. So free, you get 250 API calls a month. Not bad, so it's great for demoing, great for prototyping and evaluation. And then once you exceed those thresholds, they have different sort of tiers of plans, I guess, pricing plans. So you can see here, even at the $49 a month, you get 100,000 calls a month, right? That's a ton of interaction with the cloud, whether that's through FedEx or Twitter or Google or ESPN.com or what have you. So that's demo number 1. Not bad, right? Pretty good. Yeah, question. Yeah, good question. So today it's generating sketches, so Arduino compatible code. We have a roadmap, however, where they'll be able to generate what we call TR-RTOS code. So at TI, we have sort of industrial grade software platform called TR-RTOS. It's a very small OS that actually runs on the 16-bit, 32-bit microcontroller. It enables a lot of things like multitasking, multi-threading, ultra low power capability where it jumps to low power mode when there's nothing happening in the application. So if that's what we push our customers towards, because it's industrial grade, it's bulletproof, and you're gonna get sort of the most sort of optimized version of your application by going that route versus the Arduino route. So probably by June, we'll have the ability to not just generate the Arduino and Argia compatible code, but also the TR-RTOS sort of industrial grade code as well. And it'll be the exact same user experience. You simply pick the cloud application that you care about and the API you want to trigger. The only difference is on the drop-down, you'll find TR-RTOS as one of the options in this menu here. So good question. And that code you can then import to CCS, which is our sort of full-blown kitchen sink IDE. Yeah, good question. So I have a Tembu account, so I was able to sort of pre-populate a couple of fields. So as I go here, when I click edit, I can choose which Wi-Fi connection I want to connect to, whether it's authenticated or unsecured. So let's say it was authenticated. This is where I can put my SSID and my password. So now that that's saved in my profile, anytime I generate code, it simply adds the Wi-Fi.begin, which is the API we use to connect to Wi-Fi. Where is it? Wi-Fi status. Yeah, here it is. Wi-Fi.begin and Wi-Fi underscore SSID is a global variable that's defined here in the header file that's also generated. So this is where it populates things like your Tembu credentials as well as your Wi-Fi credentials. Yeah, good question. Well, one, that's Tembu's business model. Yep. Oh, repeat the question. Yeah, totally. Good call. So why do I want to go through Tembu as a bridge as opposed to talking to FedEx directly, Google directly, Twitter directly? You absolutely can, right? If you're savvy enough to write the HTTP client interface and the RESTful APIs with your embedded firmware, knock yourself out. One of the other benefits, however, beyond ease of use that Tembu provides is they sort of provide sort of future-proofing of those RESTful APIs. So let's say you built that FedEx application that checked the status of your package and you deploy 1 million of them. You had this awesome Kickstarter campaign. You've got 1 million of these deployed in the world, and then whatever reason, FedEx changes their API from 1.0 to 2.0, and now you've got 1 million bricks out there, and you've got to figure out, okay, how do I go and update all of these hardware platforms that I've deployed into the world? You could figure it out. I'm sure it's doable. You know, enable some sort of field bootloader to enable some sort of aftermarket update. But with Tembu, because you're going through the Tembu cloud, that interface between your connected thing and Tembu stays the same forever and ever, and Tembu absorbs the difference. So they'll make whatever updates required to talk to 2.0 of that API versus 1.0. So that's the other benefit. Yeah, please.
So what's the best practice in connecting to Wi-Fi when you have it really deployed? When you have it really deployed, you cannot rely on a particular SSID or a particular password.
Oh, totally.
It needs to hook it up to wherever this is hooked up. Right?
Yeah, good
What's
question.
the best practice for that dynamic Wi-Fi?
Yeah, I mean, there's a ton of ways to do it. Some of the ways that we've seen is through, good call. I'm so glad you're here. Question. We can't assume what SSID a customer has, right? So how do we enable the customer to provide their SSID, Wi-Fi credentials, et cetera, to the thing they just bought, your connected FedEx notifier, as an example? So we've seen a couple of implementations. What we've seen is through a USB connector. You've got some sort of PC-side application. You type in your credentials, you hit send, and it sends that information to your hardware. We've also seen an over-the-air implementation where you have an app that you download. So this is probably more familiar with a Fitbit type user experience or a Nest, where you have an app for whatever it is, the platform that you've built, and you're able to then send it over the air to the connected thing through either BLE or unprotected Wi-Fi, right? Because it's basically just blindly sending those credentials to the connected thing that's listening. So those are the two primary ways that we've seen for passing Wi-Fi credentials to a brand new connected thing. Because in many cases, they don't have an interface, right? You don't have a little tiny keyboard and a little tiny LCD screen. So in many cases, we use the phone as sort of an extension of your product. Yep, good question. So that's Tembu. That's probably all we'll talk about with Tembu. You can just see already just the cloud applications that are possible. So I highly encourage you just to try it. I mean, one, it's fun, but then secondly, it really allows you to put a proof of concept quickly together, put it in front of customers, get feedback. And like I said, I maybe only know what 10% of these cloud services here on the left even do. So my even understanding of what's possible is limited simply because I don't know what, Files Anywhere does. Maybe they're a Dropbox, I don't know. Another really cool application is Google. Not only can you send emails and stuff like that, but you can also interact with Google spreadsheets. So this could be cool for just data logging, right? Every time we exceed that moisture threshold or whatever, we can actually append a new row in a Google spreadsheet. So we're actually doing some cloud-based data logging that you can then share and monitor over time, maybe trend your data, so on and so forth. Oh man, I want to switch to a different topic, but there's so many cool things. Another really cool one is Wolfram Alpha. Who's familiar with Wolfram Alpha? Probably most of y'all, right? It got me through college. But there's a query button here. So for those that aren't familiar, Wolfram Alpha is a very powerful search engine, if you will. You can ask it anything. Like you can type in TXN, which is the TI stock ticker, and it'll give you everything from 52-week high and low to who the CEO is to everything. I can ask it silly questions like this one. I'll type it in anyway. All right, one sec. So I can type like just crazy math questions, right? And it gives me the answer in like multiple number formats. It's out of control. So suddenly my little tiny connected thing could look like a genius, right? Because I'm offloading all of that mathematical, computational stuff to the cloud. And with the help of Tembu, it makes it really easy, where I do need to sign up for Wolfram Alpha, get an app ID, but once I have that, I type that exact same query that we typed into the browser into this little code gen tool, generates a code, and suddenly your connected thing looks like a genius, right? Because it's offloading all of that to Wolfram Alpha. So that's pretty cool. And then you can ask it like stupid stuff, like what color is the sky? And it tells you like the RGB color code. It's crazy, guys. So that's just, I think, just a good demonstration of just how powerful it is to be able to offload some of this intelligence to the all-knowing cloud, right? So this little lowly, 16-bit microcontroller can start to do some pretty powerful things. Any other questions on Tembu? Who's gonna sign up for Tembu? Yes. All right, I was hoping for everyone, but that's fine. So tembu.com, that's where you can go, sign up for an account, works with our hardware, like $20, and you're ready to go doing exactly what I've done up here. Yeah. So you're gonna have to repeat the question. So you said having multiple connected things. Okay, and how would you have it all talk to Tembu? I see. What would be the best way of connecting all of these multiple things to the cloud? So you could make them all individual Wi-Fi nodes if you wanted to. What we're seeing when it comes to having a multi-node network is by using a lower power protocol for what we call edge nodes, the thing furthest away from the cloud. These edge nodes could be, if you have a SmartThings hub at home or a Wink or whatever home automation solution you've bought into, most of those things are using Z-Wave, right? It's a very low power protocol. They can run off a coin cell battery for a year. You set it on your door and you get notifications every time that door opens and closes for the next year until you have to replace the battery. You're not gonna get that same battery life with a Wi-Fi connected thing, right? Because it's 2.4 gigahertz, it's very high power, it's not optimized at all for low power capability. So using something like Zigbee or Bluetooth Low Energy or a proprietary sub-gigahertz RF protocol, those are what we recommend at the edge node because they're much lower power, easily run on a coin cell for 1 year or 2 years, and you're able to get that little bit of information you care about. Did the door open or close? Was water or moisture detected? Or did a certain amount of sound happen at a certain time of day? So what ends up happening is you basically create what we call a star network. You've got all of these edge nodes sending data whenever a certain threshold is met to a centralized gateway. And that gateway is what's connected to the cloud, either over Wi-Fi or Ethernet. So you only have sort of one connected thing you have to worry about. That could be plugged into the wall. It could be hooked up to Ethernet. You don't have to worry about low power consumption, where the edge nodes are already managing that, where only some of the information has been sort of pre-filtered and sent to the gateway to then be sent up to the cloud, which at that point it can interface with something like Tembu or any of the other cloud services. Yeah, good question. Yep.
Is that compatible with Arduino? So if I just download the Arduino open source IDE, can I hook it up to the hardware and will it just work, or do I need something else?
Yeah, good question. So the question is, can we just simply use the Arduino IDE? Unfortunately, no. We have something called Energia, which is, like I said, basically a fork of the IDE that Arduino provides. So it's the exact same user experience. It's red instead of blue. But it's all open source, it's free, it's all on GitHub. And the benefit here is that you have support for all of our Launchpad boards. So we've got about 20 different Launchpad boards today, which offer different types of integration, different capabilities. But we get the code compatibility with the Arduino ecosystem. So if there's a code example you find in Arduino land, you can absolutely run it on our hardware, which we think is a bit more optimized for production-ready applications.
What's the price range on the hardware?
Yeah, good question. So I do have a slide that kind of gives you a bird's eye view of the ecosystem. So here's some sort of a snapshot, shotgun coverage of the portfolio. So like I said, the goal is to provide some level of interaction with TI's broad portfolio. So we've got a whole bunch of connected products. We've got a bunch of analog sensor interfaces, displays, battery packs. And then at the bottom, you've got the various Launchpad boards. Today, we have about 22 different Launchpad boards, each of them offering a different level of feature sets, capabilities, specifications. And we have about 80 plus different booster packs today. They're not physically compatible with Arduino, but a lot of the same interfaces are available on our hardware. So if you wanted to, you can hook them up over wire or a breadboard. Hardware-wise, they start at just $9.99. I think the most expensive one is $29.99. The hardware setup that I am using here, the black board, which is the Launchpad, is $13 US. The Wi-Fi board's $19. So for about $33, $32, you get a reprogrammable Wi-Fi connected thing. And this is an ARM Cortex M4F. 32-bit, goes up to 80 megahertz. It has, I think, 512 kilobytes of flash. It's pretty powerful. Yep. Do you have a question?
Yeah, so we use the sensor tags that AT&T had on.
Mm-hmm.
So like 2 years ago, so I'm just curious what kind of advancements like LED chips for sensor tag.
Yeah.
If there's anything else new.
Yeah, dude, good question. So I do have a demo that will use the latest sensor tag. So 2 years ago was probably an older gen, first gen. The newer ones, they're basically triple core. There's 3 cores inside of that device. It's called the CC2650. There's an ARM Cortex M3, which is where you are spending most of your time. That's your application processor. There's a Cortex M0, which is the network processor. And all that thing does is manage your BLE connection to your phone or to your gateway or what have you. And then you've got a 3rd core, which is what we call the sensor interface. And that thing is extremely lower power, and that's what's talking to the real world, reading voltages, reading sensor data, reading ambient light data. So those 3 cores, they're highly optimized to do very specific things, and we provide an interface between those 3 cores. So you really only have to stay in the M3, the ARM Cortex M3, the application processor. But we've provided libraries and APIs to then interface with a network processor, as well as a sensor core, but it's all inside of one chip. So it's a pretty powerful device, and we'll do a quick demo there later today. But yeah, great question. Yep. Yeah, so do any of the Launchpads carry any of the DLP products or the Sartup products from TI? Not today. Launchpad is kind of more of our MCU or microcontroller strategy. If you want to play with a Satara, that's where our BeagleBone products come into play. BeagleBone is kind of the Satara development platform. They're about $50. They're kind of more of a Raspberry Pi class of device. So it runs full-blown Linux. It's very powerful. It's not going to be as low power as these products that we're talking about. But if you want to run Linux, the BeagleBone is the one you'd want to go with. DLP, we have EVMs for our DLP products. They're a bit less what we call catalog. They're not really meant for like the mass market, if you will. They're like $1,000 EVMs that we provide our traditional customers with. But they are available for sale if like you really, really, really want to develop with them. Yep. Yep. Yeah, good question. So everything that we've just showcased here, everything in the Energia IDE that I've demonstrated, that's all a BSD license. So it's all open source. You can do what you want with it as long as you're comfortable with an open source license in your end application. So it's a decision you ultimately have to make as you release your product to market. That's something that we're starting to see in the industry, right? Because if you think about it, our goal is to sell more TI silicon, right? We don't care how much these dev kits cost, right? Like, we do not want to make money on these dev kits, right? Our goal is to get into as many people's hands as possible. They come up with something big, and they start placing 1K, 10K, 100K unit orders for our silicon. And if open source code helps customers get there, that's exactly what we're going to do. So yeah, great question. Yep. Yeah, good question. So I don't think we have an XB adapter, but I mean, everyone's using the same interfaces. That one, I think, is just UART, a serial interface. And we have serial interfaces on our board. So it's not going to be plug and play. You might need a couple of wires or whatever to hook it up, but we can absolutely interface with external modules like that. Ssid Studio, which is the company we worked with to build this sensor kit, they've got 150 plus different sensor modules and actuators. So this is actually an outdated slide. They have over 150 of them now. And that's what I'm using here, from the ultrasonic sensor to the relay to the microphone to the moisture sensor that we played with. So this kit, I think, is $50. And it comes with 10 different sensors and actuators, but it also includes this sort of interposer board, this adapter, which allows us to hook up to those sensors using this ribbon cable. So this is just one example of how we are able to work with other sort of hardware ecosystems. So we're doing our best to work with as many of them as possible. Yeah.
So beyond the prototyping phase and the actual design phase, if you need to move to production,
Yeah, totally.
is it possible to do that without having hardware design in-house? Could I, once I have a prototype that works, is it possible to send that prototype to a contract manufacturer? Is there something in place to take it to the
Sure. So the question is, how can we go from this sort of stack of boards to something more production ready, right? So you can absolutely work with a contract manufacturer. So we work with a few based in China, and they'll charge you accordingly, right? I mean, if you just simply send them a stack of boards, like I said, all of these are open source hardware anyway, so they can download the schematics and the layouts from ti.com. They can then use that to sort of merge them into one optimized piece of hardware, and they're going to charge an NRE for it. So if you want to off-source that, absolutely, go for it. But you're going to have to pay for it if you're not going to do the work in-house. But we're going to do our best from a TI perspective to make sure that that is as seamless as possible. And the main way of doing that is by making sure that these are all open source hardware.
Do you want to have standard production-ready schematics? If I just need, maybe Wi-Fi and one sensor.
Yeah, sure.
Production schematic.
Yeah, and I guess that's where maybe something more like a sensor tag might come into play. So this little guy here, this is a dev board, $30, open source hardware. And for the most part, if you're happy with this form factor, send this design to a contract manufacturer. And without a doubt, they could build you 10,000 of these. This comes with 10 different sensors though. So you're gonna have to say, hey, I don't care about that sensor, get rid of it. And maybe the contract manufacturer can make those small modifications to make it a bit more optimized from a size perspective or fit whatever physical requirements you have.
So do you have a catalog of this?
So this, we do. So this is just one example of a what we call a reference design. We also have a repository of reference designs on the website called ti.com/ti-designs. And in many cases, these are applications that we see in the industry. So we identify a trend, we're gonna go ahead and build a reference design for it, and these are production ready. So if you want a high fidelity headphone amplifier, go for it. The design files are there, schematics, the layout, the bill of materials, you've got a user guide, so you have all the information you or the contract manufacturer would need to go ahead and take this to production. And we've got, I think, 2,000 designs here in this repository. You can search for whatever it is you might need. Yep, good question. Cool. So that was Tembu. That was a very quick demo. I'm going to showcase another solution now using Mqtt, which has been a buzzword in the IoT space. Is anyone familiar with Mqtt? There's a few of you guys. It's pretty magical. So when you think about the internet, right? They're mostly interfacing through RESTful APIs. The web, traditionally, for the last 10, 15 years, however old the internet is, I don't even know, they're all interacting through RESTful interfaces. And these are huge, beefy servers that can do string manipulation, and it's really easy for them to communicate in that way through these RESTful interfaces, RESTful APIs. Sure, we can go ahead and do it, right? In the case of talking to Tembu, we're doing a RESTful interface to the Tembu cloud, and we can squeak by. But these little tiny microcontrollers, it's not ideal. It's also not very real time because HTTP requests are very much kind of, hey, do you have information for me? Oh yeah, I sure do, here it is. It's kind of a polling mechanism, which is slow and not real time at all. But for connected products like this one, and when I open my door in my house or if someone breaks my window, I want that notification instantly. And that's where Mqtt can come in to play. Mqtt is lighter weight than HTTP. It's faster. You get about 100 millisecond latency, so it's more or less instant. And we, fortunately enough, have a bunch of code examples that enable us to communicate using that protocol. So very, very rough demo, just to kind of introduce what Mqtt is and how it works. I'm going to use a cloud service from IBM called Node-RED. Has anyone seen this before? So a few of you all have extremely powerful tool for the more hardware savvy guy like me. It's basically LabVIEW for IoT. It's a visual tool. You can wire nodes up together and it will generate JavaScript code for you. So in this case, this is running on Node.js, a JavaScript runtime hosted in IBM's cloud server somewhere. I can run this on anything capable of hosting a Node.js runtime, whether that's a BeagleBone, a Raspberry Pi, my laptop, or someone's cloud server somewhere else. So in this case, this is running remotely in some IBM server somewhere. And this enables me to, again, build a very simple JavaScript application. So it works by creating what they call flows. I can wire them up just like this and hit the deploy button. And once I hit deploy, this application is running somewhere else, running remotely, 24 hours a day. And this is a very rudimentary example. All it will do is print out a timestamp every time I hit that button. So it'll just print out the system timestamp. It flows out, hits the payload debug button or debug node, and prints it out to the terminal. So that's a very simple flow, kind of how Node-RED works. So in this case, I have a quote-unquote physical line. I don't want that physical line connection to be there. I want to use Mqtt as an interface instead. So fortunately enough, they have Mqtt nodes as well. They have both a publishing node as well as a subscription node. So Mqtt is a pub-sub communication protocol. So you've got basically 3 players. You have a publisher, you have a subscriber who can receive those messages, and in the middle you have a messaging broker. And the messaging broker can be running in the cloud, it can be running locally on-prem on a Raspberry Pi or a Beagle, and basically it's just handling all of those messages between publishers and subscribers. What's cool about Mqtt is that it's a one-to-one or a one-to-many communication protocol as well. So with HTTP, it's a bit more personal, right? It's a one-on-one communication. But with Mqtt, it's a bit more like Twitter for hardware, where depending on how many subscribers I have, they'll all receive my messages. So for a publisher and subscriber to communicate with each other, first and foremost, they need to be connected to the same broker. And Node-RED, this visualization tool, makes it really easy. I simply double-click on my Mqtt node, and I provide the IP address and port number of the messaging broker that I'm using. And Eclipse.org provides a open, free, public MQTT broker that you can use for prototyping purposes. So this is free, and I'm just using it again just for demos. But if you wanted to, you can buy your own MQTT broker. You can host your own if you want to. So as long as my publisher and subscriber are connected to that broker, I simply need a consistent, unique topic. So I'm going to publish to that broker a specific message using a specific topic, and my subscriber needs to be obviously connected to the same broker, but subscribe to that topic. And just like that, we've merged or linked these publishers and subscribers together so that when I hit the timestamp button, I still get the timestamp printing to the debug window. So you can see that it was pretty much real time, right? Like that's the beauty of MQTT. It's more or less instant. Again, you get that 100 millisecond latency. And in this case, it's going from a MQTT client here to some broker somewhere else in the world, coming back, hitting this guy, and then printing to the debug console here. So in this case, this is cool. It's cloud-to-cloud communication. That's great. That's a great use case for MQTT. But in this case, I want my launchpad to be MQTT messaging sensor data to this guy instead. So all we're going to do is we're going to say, hey, you know what? I don't need you messaging anything. I want to write the MQTT publish code here on my embedded hardware. And exact same hardware setup that we had before, sensor, microcontroller, Wi-Fi module. So I've got a couple of code examples that are already here. And I can walk through the code just very quickly. It's not too bad. It might look scary, but hopefully it's not too bad once I walk through it. So this is the code example that ships with Energia. Energia, again, is our Arduino compatible development environment. So the first thing we do is we include a couple of libraries that we're using. We're using a Json library, which is what we're going to use to format our payload. Are you familiar with JSON? Yeah, so it's basically like XML, right? It's a way of formatting, organizing data so that it's easily parsed. And we, fortunately enough, have a JSON encode and decode library so that our Launchpad can organize and read JSON data. I'm also going to include a SPI library. That's the physical interface between my microcontroller and Wi-Fi module. I'm going to obviously need a Wi-Fi library since that's how we're connecting to the cloud. And then I need my MQTT library, which is the communication protocol for pubbing and subbing data. Next thing is we need our SSID for our password. And then we need to provide the IP address or URL for the MQTT broker that we want to connect to. And if you remember, that's the exact same one that our cloud application is connected to. Perfect, great start. So I'm just going to scroll down now. So if you're familiar with an Arduino sort of environment, you've got a setup and a loop function, right? Setup runs once at the beginning of code execution. That's where you might set up the foundation of your application, initialize variables, initialize peripherals. First thing we do is we initialize our serial port at a certain speed. And then we print a couple of diagnostic messages to the terminal. And we say, hey, we're going to connect to this network that was defined earlier in the SSID variable. And one line of code, we connect to Wi-Fi, Wi-Fi.begin. We simply pass in the Wi-Fi SSID name. We'll go ahead and print a couple of decimals while we're connecting. Cool. And once we're connected, we print a couple of decimals until our microcontroller board gets an IP address. And that's it in setup. All we did was initialize our serial port, connect to Wi-Fi. The loop is where things get a bit more interesting. The first thing we do is we check to see if we're connected to the MQTT broker. If not, let's try to connect using the client.connect API. And if we are able to connect, we simply print out a diagnostic message that says connection success. Great. Then we're going to use a function that we created called createMessage. And this is where the JSON library earlier that we imported comes into play. So this is where we're able to add objects into the JSON message. And what's interesting here is we have a global variable called sensor. And this is actually being updated in a separate task. So what's unique about what we've done with Energia versus Arduino is we actually have multitasking, where you can actually run multiple Arduino sketches in parallel on the same hardware. And what that looks like, it's actually pretty simple. It's simply a different setup in loop pair that's opened up in another tab. So we've got two tabs here, each running a different sketch, running in parallel, and we're using very simple global variables to exchange data between these two tasks. These are cooperative multitasking, so they're operating at the same priority, and they're basically just yielding to each other. When one task has nothing to do, he says, hey, task, go ahead and take over. So this task here is simply reading the analog value at pin 23, which if you remember is where our ambient light sensor is connected to, updating the global variable sensor, and we're doing that 4 times a second. And this task is just churning away, updating that global variable. Yep.
So you're saying so you can have 2 or 3 or 4
Yeah.
on the
Same
same board.
board.
Can they monitor the same pins and the same sensor?
Yeah, totally. So we can set up semaphores if we want to, just to manage hardware resources. We can do mailboxing if we wanted to. But in this very simple demo, we're just using a global variable to exchange data between multiple tasks. It's true multitasking, yeah. Exactly. Was there a question? Depends on the device. So this device has 1K of RAM, so quite a few. On the hardware resources, yeah, and you'll get like an error if it thinks that you're gonna die. So in this case, very simple. We've just got 2 tasks. One task that's updating this global variable with the latest and greatest sensor reading. This task is simply creating an updated JSON message based on that global variable. So whatever that value is based on the other task activity, we're just gonna go ahead and add it to this JSON message. So going back to the loop function, so again, the first thing we need to do is connect to the broker. Once we're connected to the broker, we create an updated JSON message with the latest sensor value that's being updated by the other task. And what's cool about that is that you might have multiple tasks, one for a moisture sensor, another one for an ambient light sensor, another one for a display. So that display might be reading those same global variables that your MQTT task is reading, but all it's doing is updating a screen where you get sort of real-time readings visualized on an LCD. So it really enables you to modularize your code. If you've developed with an Arduino before, you've probably spent hours finding 12 different code examples and figuring out how do I merge it into one big super loop. Totally fine, you can do that, and you can do that here as well. But what's powerful now is that instead of figuring out how to merge those into one big super loop, just run those 5 code examples at the same time and then figure out how you exchange data when it makes sense through global variables or mailboxing or events. So it's just a different way of rapid prototyping. So once we have an updated JSON message, we simply call this API called client.publish, and we publish to a unique topic, and we have a pointer to our JSON message. So when you think about it, code's pretty simple, right? Set up your serial port, connect to Wi-Fi, connect to the MQTT broker, create a JSON message with the updated sensor data, and publish it to the cloud using MQTT. And we're just gonna loop forever and ever, sending the latest, greatest sensor data. So the first thing we'll do is we'll go here and say, hey, what was that topic again? It was this. So I'm gonna copy that. Hit deploy here, make sure the application is running. And then I'm gonna go back to my code and replace that topic with the one that we're already subscribed to in the cloud. So I'm gonna go ahead and hit go. It'll compile that code, flash our hardware, and then hopefully in like a minute or so, once the code is done running, this guy will connect to Wi-Fi, and then we'll start to see the latest and greatest sensor reading on the other side of the fence in the cloud. So let's let it update here. Okay. Change the baud rate. There we go. So you can see publish success. It's sending data every 500 milliseconds with the latest ambient light values. Cover it up, value goes down appropriately. Let go, value goes up. And then I jump here to node red, and you get our data. So this is 100 millisecond latency, right? So I'm going to cover it up, and you'll see that that value goes down instantly. And this is, I could be anywhere in the world and getting the exact same data that we're seeing here, right? They're physically connected to each other over USB for power, but they have no idea where they are, right? This could be on opposite sides of the world, communicating over MQTT, and we're able to then get that sensor value. And just like before, taking advantage of the modular hardware, I don't care about light anymore. I want to care about moisture instead. So just wire it up, and now we've got an internet-connected moisture sensor. There we go. So that's pretty cool. So now our embedded device is talking MQTT. We get the real-time benefits of MQTT. What's great about MQTT and the library we've created is that it's also capable of being a subscriber. So if we want to subscribe to messages coming from another thing or the cloud, we can enable bidirectional communication as well. That's actually what's happening on this broken demo. I don't know why it keeps on screwing up. But this guy is basically subscribed to a topic, and anytime we publish to that topic, it prints it out here on the display. I think I actually have it running here. So this is where we have a Twitter node. listening to the hashtag DSW16, and anytime there's a tweet with that hashtag, that string just gets printed out and publishes to this topic, and that topic is what that guy is subscribed to. So I can actually just force a message here. So it says, hello, startup weekend, hi, okay, deploy, and I'm just gonna go ahead and inject that. So it's gonna publish that message to this guy, and once this string is finished, hopefully we get the updated hello, startup weekend, hi. So pretty cool. And that's kind of the benefit of using a tool like Node-RED. So again, I'm a hardware guy. I would die trying to figure out OAuth and talking to the Twitter API and all of that stuff. But Node-RED already provides a Twitter node, so I just had to drag that in. I simply authenticated a Twitter handle to it and provided the hashtag that I cared about. And now anytime there's a tweet with that hashtag, it flows out, and I can do whatever I want with that information. And in this case, publishing it to that subscriber over there. Cool. So let's open up the debug view again. Any questions while this is happening? Yep. Yeah. So Mqtt is an industrial standard. You don't have any hardware. I mean, in this case, we're simply using a cloud Mqtt broker. So there's companies out there that provide it as a paid service where they'll host a broker for you, they'll guarantee uptime, they can provide an authenticated Mqtt broker so that only you can publish and subscribe to certain topics. Or if you want to, you can completely run it on your own. So there's available resources where you can deploy your own Mqtt broker running on-prem on a BeagleBone or a Raspberry Pi or a laptop. Yep.
So when you're running you're assigning the sensor values to the global variable. So if you can run multiple tasks simultaneously, then you can also have multiple global variables.
Yeah.
So they're all being updated in their own time.
Independently,
And
exactly.
you can read all of them within code. You just see whatever the latest values are at the time.
Exactly.
And it's transmitting the whole time.
Yep.
Now, how often does it re-update the network connection? Is it always?
Yeah, so with Mqtt, once you connect to that broker, it opens up a socket. And at that point, you're just constantly connected.
Continually try and connect, disconnect.
Exactly.
Connects and holds on.
That's right.
And so if the network goes down, does it automatically reconnect?
Yeah, and that's what's going on here in our code where we had a client.connect Boolean. So if connected, don't worry about it, you're okay. Else, try to reconnect. So this will more or less keep a persistent connection.
So much more than that, then if it is disconnected, can it start logging all of the information so that when it does connect, it can
Yeah,
log
batch.
the environment?
Yeah, totally. You can do that with the embedded memory of the device. Like I said, it has about 1 kilobyte of RAM. It has 512 kilobytes of flash. Or if you want to, hook it up to an SD card, store it there, and then do a batch upload once you're reconnected. Yeah, exactly. In this case, yes. There's paid for services that have a value add on top of Mqtt where they can do things like that. They'll keep 30 days of historical messages, a year, but you'll have to pay for that service if you want. Or you manage it yourself, right? If you've got a BeagleBone somewhere, intercepting those messages, knock yourself out. Yeah.
Is it using a TCP connection?
Yeah, it's on top of TCP.
So does it have a heap alive? So the problem is that if you have a client
Yeah.
connected to a Wi-Fi network on TCP and there's no messages going across, then the firewall might just
Boot you off or something like that. Yeah, so there is a ability that's a variable in the library. It's hidden, it's not exposed to you as the developer. If you wanted to, you can go into a .h file and change that keep alive time. I think by default it's like 10 seconds or something like that, I can't remember. Yep, but it's completely modifiable if you'd like. So just a few more things on, so now that we're receiving this data, you can start to do, oh, sorry, yep. Is that all documented and stuff like that? Like sensor or whatever, yeah. Let's see here. So Node-RED, you can do a few things, right? I mean, what's cool about having a cloud now is you have additional flexibility, right? You can make a decision about where do I maybe run some logic? Do I do my if statement and math on the embedded side? Do I have some sort of if statement here? Or do I simply send all of my data to the cloud, which will then do the analytics and have the if statement? So it's completely up to you, right? It just depends on the type of application you're trying to do. Do you want to optimize for performance? Do you want to optimize for low power? In most of our applications, we're more optimized for low power because it's a very low power microcontroller. So we might do some sort of high level analytics here and only send data to the cloud when we absolutely have to, because that's the biggest power consumer is the Wi-Fi connection. So if we can minimize the times of connecting and sending data, the better for the customer, right? Because that means they're changing batteries less often. Is that the answer to your question? Okay, cool. So now that we're getting data, just a few things of what you can do in Node-RED. So if you're JavaScript savvy, knock yourself out. You can do a lot of really powerful things. In this case, you can do things like visualization. There's a cloud service called Freeboard, which makes it really easy to visualize your data. There's another cloud service called Twilio. They provide, much like Nextmo, an API for triggering text messages and voice calls. And then again, if you're JavaScript savvy, they have a complete JavaScript IDE that you can drag in called the function block. And this is just a full open-ended JavaScript IDE. So if you're JavaScript savvy, knock yourself out. You can do a whole bunch of things here, like manipulation of your data, etc. So let's go ahead and quickly do the visualization piece. So I'm going to use another interface called Dweet IO. It's very similar to Mqtt. It's a pub-sub communication protocol. And I'm going to send data to another cloud service that provides a really slick-looking visualization capability called Freeboard. Has anyone heard of Freeboard yet? Okay, so one of y'all, awesome. Super cool. It's free for the most part. You can do a paid-for account if you want further flexibility. So I'm just going to log into my account real quick. Okay. And I can create a dashboard, so DSW16, create. And what's cool about that is that I can add a data source. So in this case, Dweet IO is the interface that I've chosen in Node-RED. So anytime my cloud service receives data, it's simply going to forward it on to Dweet IO. And I'm going to just need to provide it with a unique ID. And I'm going to copy that to Freeboard. So thing name and key. And I'm going to hit save. Okay, let's see here. And then I'm going to hit deploy here. So now this application is updated. It's receiving data over MQTT and then forwarding it on to Freeboard using Dweet IO. So let's see here. Is it working? There you go. So we should be getting our sensor data. We should be forwarding it to Dweet. And is it working? Maybe I need to update the name. What am I doing wrong here? So you can see that there's a bunch of other stuff going on here. We actually have a few other applications running in Node-RED, so that's why our debug window is so hairy right now. Oh, I see what I did wrong. I'm connected to the wrong MQTT broker. So we're publishing to this topic, right, from our connected thing. There you go. Silly me. There you go. So we can confirm that we are indeed receiving data here in Freeboard because that timestamp on the top right is updating. So every time, so we're sending, what, twice a second, right, from our connected thing. sending it over to Bluemix, which is where our Node-RED is hosted. It's in the IBM cloud, forwarding it on a freeboard, and we can guarantee or sort of confirm that we're closing the loop because that timestamp was updating. So now I can add panes here, and this is where I can start building the widget. So I can choose a few sort of out-of-the-box GUI components. So let's say I want a gauge, and I can then link it to a data source. Let's see here. Uh-oh, my connection went down. Let's give it a second. Let's see if it'll come back up here. Oh no. So that's a downside of working in the cloud sometimes, is that in this case I'm using a free account, so they don't guarantee uptime. But if you're paying IBM, they will guarantee uptime for you. So in this case, looks like my server went down. So we'll give it a second for it to come back up. So while the server is resetting here, this is where we can start parsing the JSON. So in this case, we care about a certain data type inside of the JSON object. So this is where we can choose which element in the JSON object we care about. And in this case, it was the sensor data. So once our cloud service pops back up here, this should hopefully start refreshing. And then we'll be able to then visualize our sensor data here on the widget. There you go, looks like it's back up. There you go. So you can see the timestamp is updating again. I'm just gonna click on gauge, and then I'm gonna start picking and choosing the component that I care about. One last thing I need to do. So what's happening here is I'm getting a string from my MQTT broker. I actually don't want a string, I actually want a JSON object. So there's a JSON node here that will convert the string to a JSON object, which will then be parsable. So we simply have to add that in the middle here, hit deploy, confirm deploy. And now we should be able to parse the JSON on this side. So we'll pick the gauge, pick the data source. There you go. So you can see now it's actually identifying the elements inside of that JSON message. We care about the sensor component, hit that. Change the range of the gauge and hit save. So now that should be the moisture values. So if I short it a little bit, you can see the values go up. Probably more interesting is if we have a knob here. So I'm gonna replace it with a little turn knob. There we go, replace it with a turn knob, turn it all the way to the right. You can see the value goes up, put it somewhere in the middle, goes to the middle, turn it all the way down. So in this case, very simply able to create a visualization platform. And this is all public. This is a public dashboard, so I can actually email this URL to a customer, and I could be sitting in my office, they could be somewhere else. I can make some modifications, turn the sensor upside down, whatever it is, and the customer will visualize that real-time data completely somewhere else. If you're talking to like an investor, an angel guy, and they're remote, you can just send them this URL, and immediately they'll be able to kind of see what your connected thing is doing. You can even make it look a bit more fancy. Like I think there's a image component here. So if you want to add your logo, it makes it super easy. Just click on picture and just type in the image URL, and it'll add it to the dashboard. So you can already start to create a pretty good looking dashboard for your connected thing. Cool. So the last thing I'll do is I'll quickly demonstrate the sensor tag, and then I'll open up for Q&A. So sensor tag is another development tool that we have at TI. It's based on our CC2650 device, which is the Bluetooth low energy microcontroller. So there's a microcontroller, reprogrammable, as well as integrated BLE on a little chip. So you don't have to have two different devices on your bill of materials. It's one device. And this is an open source reference design that we provide. We provide the CAD files for the enclosure. We provide the bill of materials for the PCB, the schematic, the layout, everything you need to completely replicate this if you wanted to, and just switch out the logo. So in this case, I'll turn it on. There's a little power button here. And what it'll do is it'll start advertising, and I'll be able to connect to it using my, my phone app. So you can download it from the iOS or Play Store. And what's cool about this particular experience is that we can demonstrate a very simple sort of point-to-point connection, where this is simply streaming the 10 different sensor data to your phone and visualizing it. So that might be kind of like a Fitbit type of application. But in addition to that, we can also use the phone as a gateway, where not only will the sensor data, which is going to be JSON encoded, be sent to your phone, but we can actually forward that data up to the cloud as well, where your phone will serve as that gateway or bridge between your local area network and the cloud. So let me open up the application here, and then I'll show it on the webcam so you can even see what's going on a bit more closely. So it's called the sensor tag app. You can just look for it. I'm going to scan for BLE devices, and you can see that it found it. So I'm going to open up a webcam here. There we go. You can see it found it. I'm going to hit the connect button. And this device is basically advertising all of its capabilities. So the app is able to dynamically visualize that, oh, this thing is giving me temperature data, it's giving me I/O data, it's giving me humidity data, barometric data. You can see that there's a motion sensor there as well, so you can get accelerometer, ambient light with the lux, key press. So if there's a little button here. So when I push the button, you can see the value goes up and down pretty quickly. So all that data is being sent over BLE from my thing to the phone. Cool. So if you're, again, an iOS or Android developer, you can live in that world, you're super savvy. This hardware here could more or less simulate a connected thing for you. And let's say you're reading the raw accelerometer data, you could have your pedometer algorithm running on your phone, or you can have it running on the connected thing. It's completely up to you, right, depending on your use case. Cool. So at the very top of this application is a send to cloud button. So this is where we can say, hey, you know what? It's great that I have my sensor data locally on my phone, but I also want to send it up to the cloud. So I'm going to hit the push to cloud toggle. It's now in the on position. We get a little diagram there that says, hey, it should be working. And I can click open in browser. And this will open up a web page running on the IBM cloud. And again, this is a page you can send to anyone in the world, and they'll see all of the sensor data there. So in this case, that's the ambient light sensor. I'm going to cover up the sensor value, and you can see the sensor reading goes down. So this is a public website that anyone can see, and we're using the phone as a gateway. Furthermore, since I'm also sending that data to the cloud now, I can actually go back to Node-RED, close this guy. Yeah, totally. So we have a separate debugger module, so you have to disassemble it. There's a JTAG connector you can plug into, and then plug it in over USB, and at that point you can reprogram it. Let's see here. So I'm just going to go back to Node-RED. We have a Ibm Iot Node. This is where we can drag it in, double-click on it, and we simply provide the device ID, which is displayed here on the website or the app. I'm just going to type it in real quick. 68C90B17DA89. And hopefully no typos. I'm just going to hook it up to this debug node here now. I'm going to disconnect these other guys. Hit deploy, confirm deploy. Let's see here. And then there you go. You can see the JSON encoded messages coming from my sensor tag. So now, again, just like before, you can parse that JSON, do whatever you want with that data, send it to Twitter, visualize it in Freeboard. You can even data log it into MongoDB. So there's a MongoDB node here that's pretty powerful. Let's see here. Oh. Where is it? And you can just wire it up, and then they have a save function. So every time it receives a message, save it to MongoDB, and then you can use MongoDB's RESTful APIs to pull data from that database. So pretty powerful stuff. So I think I've got like 6 minutes. I probably spent too much time on some of these demos, but hopefully that was helpful. Again, the main goal here was to just showcase the breadth of tools that are available. Not all of them are scary. A lot of them are actually pretty intuitive and easy and affordable. So to just kind of end on where you guys can go for more information, let me pull up a slide here. Let's see, window. I don't know why this video is so huge. It's very clear I'm a MacBook noob. Anyone know how to fix this? What was that? Hit escape? Okay, let me click into it maybe, and then hit escape. No, didn't like that. Let me force quit the cam app. It's not even showing up here. It's all right, we tried. Let's see here, what can I do? All right, I'll just open up this. So to get more information, like I said, you can send me an email. You can follow me on Twitter. Here's my Twitter handle, so you guys can DM me if you need to. So that's my Twitter handle. So you can follow me on Twitter, tweet at me, and I can follow up with more information. ti.com/launchpad, where you can learn all about the ecosystem. You'll find all the tutorials and demos that we went through here. You can also see the breadth of our portfolio and the various launchpads that we have. You can buy them direct from us. You can buy them from DigiKey, Mauser, Element 14, Makershed, all of those guys. Software offerings, if you click here on software, this is where you can find and download link to Energia, as well as our traditional environments. I didn't touch on it, but we also have a cloud-based IDE called CCS Cloud. So if you want to do all your development in a web browser, you can actually do so, where you don't need to download or install anything. It completely runs in the cloud. It's pretty powerful. So if you're familiar with Mbed, it's a very similar user experience. We also have integration to GitHub, so if you want to push and pull from GitHub, it provides a really nice interface for that. We don't yet, but we're actively looking at it. And then again, that's my email, so if y'all want to reach out to me directly, feel free to send me a note. But yeah, I think that's it. Hopefully that was helpful, guys. Any questions? Yeah. One more time, sorry. Oh yeah. So
Are we supposed to use that only there, or like is a place available?
yeah, so you don't have to use IBM at all. So Hackster.io, I don't know if you're familiar with these guys. They've got a really nice platform. We've got about 200 different projects here. So if you go here and click on Launchpad, you'll see all the different projects that are available, various tutorials. And we have tutorials where we're talking to all the different cloud services. So we're very much focused on non-proprietary communication interfaces. So Mqtt, as we talked about, it's an industry standard. Amazon AWS supports it. IBM Bluemix supports it. I think Microsoft Azure is looking at using it. Right now, they're an HTTP interface only, but Mqtt should be coming. So once you're talking Mqtt, you can more or less send and receive data from any of these cloud services that support that protocol. So it's pretty flexible. Yep. Yeah, sure. So we are working with Telit to build a booster pack that features one of their 2G, 3G modules, and then that will just communicate over AT commands. So that won't come out though until probably September of this year. So we are looking at enabling cellular networks, but we'd have to do that through third parties because TI is not in the module business or the cellular module business. We're simply looking at BLE, Wi-Fi, sub-gigahertz, Zigbee, kind of the traditional sub-gigahertz, 2.4 gigahertz technologies. Yep. Basically, right, like that way, Dallas, yeah. So we're at the headquarters. Yeah, so we try to do events like this all the time. So appreciate the invite, man. A lot of fun. We love doing this stuff. Oh, absolutely. Totally. Yeah, and I meant for this to be hands-on. I'll take full responsibility. I didn't come quite as prepared to get everyone up and running on a computer in an hour and a half. But hopefully the demos just showcase that everything I did is 100% repeatable and replicable, so. Yep. Yeah, so that is the MSP432. So that was the exact same board that I used. The goal was that I would get you guys up and running, programming it, but like I said, I just didn't come prepared enough. You will need a PC for that, yeah, to load it with some code. So we do have a web app for our BLE Launchpad. So we have a Launchpad that has the exact same device as the little sensor tag module. And this talks, or that Wi-Fi, or I'm sorry, that Bluetooth Low Energy Launchpad talks to the exact same app that I showcased here. And that app enables you to, again, receive data coming from either the sensor tag or the Launchpad, and then can forward it up to the cloud. So it's a TI app. We even released the source code for the app. So if you wanted to use it as a starting point for your own application, you can download the source files, fork it, create your own branded solution if you want to. But it's an app that we've open sourced. Yep.
So do you know, I saw, you had mentioned that Twilio, that they've got an interface for Twilio on Node-RED. Do you know if they communicate on Clevo as well? Do they have Clevo on?
Good question. What's great about Node-RED is that it's all open source on GitHub. So there's a growing sort of pool of new nodes. So I'm not familiar with that one specifically, but like I said, they do also have that generic HTTP block. So, or I'm sorry, JavaScript block. So if you're savvy enough, you could write the APIs yourself if you're able to write the RESTful interface. Yep. Cool. Yeah, and I guess that's it. So thanks everybody. Again, if you need to reach out to me, my email is adrianf@ti.com. Thanks y'all.